On Monday morning, a commit goes to staging. The pipeline is green. The build passed, the tests passed, and the deploy passed. It runs all week without a problem. On Friday afternoon, you promote that same commit to production. 20 minutes later, production starts throwing errors that never appeared in staging. Same commit, same tests. Two different programs. We usually picture a pipeline like this: push code, run tests, and deploy when everything is green. But that picture skips things between the green checkmark and the people using the software. So what did you actually deploy? A deploy doesn't ship the commit by itself. It ships something built from that commit. That includes your code, every dependency, the base image, and anything added by the tool chain or build machine. Together, they make the package that actually runs. That's the artifact. It might be a container image, a jar file, or a binary. Here's the problem. Your build instructions are a recipe, and the artifact is the result. Your Docker file might say from node 20, but node 20 is a tag that can move. On Monday, it pointed to one image. On Thursday, the maintainers released a patch and moved the tag. Nothing changed in your repository, so you didn't get any warning. Staging kept running the artifact built on Monday. On Friday, the pipeline rebuilt the same commit for production. It used the same recipe, but now the ingredients were different. Production got a build that staging had never tested. A simple rule prevents this: build once. After the tests pass, the pipeline creates one artifact and gives it a digest. The digest is a fingerprint of its exact contents. Any change produces a new digest. The pipeline stores the artifact in a registry, and nothing downstream rebuilds it. Staging and production deploy the artifact by that digest. The registry also keeps the older artifacts, each with its own digest. This gives you the same bits in every environment, but the environments themselves aren't the same. Development, staging, and production use different databases, keys, and service addresses. If the artifact stays the same, where do those differences go? They go in the environment's configuration. The artifact contains the code, and the environment provides the settings. The same image starts in development and reads the development database address. In staging, it reads the staging address. Each release pairs the artifact with the environment's configuration. The artifact itself doesn't change. What changes is the evidence you have. Development shows that the artifact starts. Staging shows that it can handle a day of realistic traffic. You might also require someone to approve it before production. Each check gives you more confidence, but the artifact itself doesn't change. That gives you a useful debugging shortcut. If the exact same artifact behaves differently in production, you can stop looking for a difference in the code you built. You can focus on the environment, including its configuration, data, infrastructure, traffic, runtime state, and external services. That can save a lot of time. There's still something staging can't fully test. Staging traffic is simulated. Real traffic comes from real people. No matter how good your checks are, real traffic can expose problems you didn't see earlier. The goal is to limit how many users see a problem before you catch it. The simplest option is a rolling deployment. Imagine 10 servers behind a load balancer. Take 2 out of service, deploy the new artifact to them, put them back, and then move to the next 2. You don't need a second environment, and you never change everything at once. But the old and new versions run side by side during the rollout. If you need to go back, you have to deploy the old version across the fleet. Blue-green uses more infrastructure so you can switch faster. You run 2 matching production environments. Blue serves users while you deploy the new artifact to green. Green doesn't receive live traffic yet, so you can test it first. Then you switch the router, and all traffic moves to green. If something goes wrong, you can switch back in seconds. The trade-off is cost because you're running 2 environments. When you switch, 100% of users move to the new version at once. A canary limits that first exposure. Send 1% of traffic to the new artifact while the other 99% stays on the old one. The old version gives you a live baseline. Compare the two versions for error rate and latency. If it looks healthy for an hour, send 10% of traffic to it, then 50, and then all. Real users still test the release, but only a small group sees it first. On July 19, 2024, CrowdStrike sent a configuration update for its Falcon security agent to Windows machines around the world. The update went out at once. The file triggered a bug in the agent. Because the agent ran deep inside Windows, it took the machine down with it. About 8.5 million machines crashed. CrowdStrike released a revert 78 minutes later, but it didn't help many of the affected machines. A machine that crashes during boot can't download the fix. In its root cause analysis, CrowdStrike said it would add staged deployment rings, starting with a canary. The scale matters here. 1% of 8.5 million is 85,000. That's still a serious incident, but it isn't 8.5 million. Rolling, blue-green, and canary deployments all manage the same risk. They control how much of production changes before you know the release is safe. Now suppose the canary metrics look bad. The registry still has last week's artifact unchanged under its original digest. Deploy that artifact to production by its digest. That's the rollback. A rollback doesn't need a separate mechanism. It's a normal deployment using an older artifact. It works because the pipeline built the artifact once and kept it. That gives you a known version to restore. Last week's artifact has already run under real production traffic. Sometimes it makes sense to fix forward instead. If the bug is a one-line change and the pipeline is fast, you can commit the fix and deploy a new artifact. But if the pipeline takes 40 minutes while production is failing, waiting for a new build adds risk. Roll back first, then make the fix without the same time pressure. The database can make this harder. Both versions use it. If the new deployment changed the schema, the old artifact might not understand the new tables. To keep rollback safe, the new schema needs to remain compatible with the previous version. That topic deserves its own video. Now replay that Friday. The commit is built once on Monday. The exact artifact that runs in staging all week is the one production receives. Thursday's patch never enters the build. If another problem slips through, 1% of production traffic reaches the new artifact first, and last week's artifact is ready to deploy. The problem affects fewer people, and you have a quick way back. That's what the pipeline is really for. Tests are part of it. Its larger job is to track the same artifact from build to production and to make recovery simple when something goes wrong. Promote the bits, not the recipe.